Example 3, adding a constant to an input. Returning to our building airflow example from figure 3, suppose that in autumn the facility manager decides that the original venting plans starts too late and wants to begin the entire venting program 2 hours earlier. We want to sketch a graph of the new function. We can set v of t to be the original program, and we can call f of t to be the revised program. So v of t is equal to the original venting plan, where f of t represents starting 2 hours sooner. So in the new graph, at each time, the airflow is the same as the original function v was 2 hours later. For example, in the original function v, the airflow starts to change at 8 a.m., whereas for the function f, the airflow starts to change at 6 a.m. The comparable function values are v of 8, which is equal to f of 6. So if we take a look at figure 6, we notice also that the vent first opened to 220 square feet at 10 a.m. under the original plan, while under the new plan, the vents reach 220 square feet at 8 a.m. So v of t is equal to f of 8. In both cases, we see that because f of t starts 2 hours sooner, h is equal to -2. And that means the same output values are reached when f of t is equal to v of t minus -2, which is v of t plus 2. So what happened is that we shifted it to the left 2 units. So note that v of t plus 2 has the effect of shifting the graph to the left. Horizontal changes or inside changes affect the domain of a function, the input, instead of the range, and often seem counterintuitive. The new function f of t uses the same outputs as v of t, but matches those outputs to inputs 2 hours earlier than those of v of t. Said another way, we must add 2 hours to the input of v to find the corresponding output for f. So f of t would equal v of t plus 2.